So today we will be learning about identifiers. So we will be starting with introduction to identifiers. Here it is written labeling the architecture. In our previous topics we looked at raw variables like name and age, but how does Python resolve these words without collisions? The system relies on identifiers. Just as human names prevent a teacher from addressing a class with ambiguous terms like hey you, identifiers allows Python to distinguish programmatic tokens such as name equal to open, mapping concentrate identifiers, age equal to 19, college equal to LPU. These are the identifiers we are using to tell the Python command that what we want to tell. Here identifiers tell Python exactly what reference to load. Now, what is an identifier? An identifier is a user-defined name given to any programmable element within your code architecture to isolate it during memory lockups and runtime execution. So this is actual identifier is the name given to the programmable element which stores or memory lockups our uh, things we need to store, such as in student name equal to Rahul. Rahul is being stored in this variable student name. Student name response represents the structural identifier token while Rahul remains a string object literal. Yet the student name represents the structural identifier, whereas this is the thing that needs to be stored in it. The scope of application: variables, functions, classes, objects, modules, packages. Now, why do we need identifiers? Preventing namespace collisions. Imagine a hospital complex where doctors, rooms, patients, and prescription items shared identical level parameters. The operational pipeline would halt immediately. Explicit identifiers map logical separation across the internal scope directory table, routing instruction to the intended data targets. So these are the main reason why we use the identifiers. Otherwise, if we don't use identifiers, there can be namespace collisions which we need to prevent, and as a result we use identifiers. Here independent scope tracking paths. Examples are given: name equal to Rahul, marks equal to 95, CGPA 8.5. Each unique level routes to an independent memory location. Every identifier uniquely labeled routes to an independent memory location. That's why we use identifiers. Now, systematic mapping categories. Image showing an architectural hierarchy branching an identifier route down to separate application leaves, variables, functions, class, and modules. Here, variables, age, and student name. These are the examples of variable. These are the examples of system mapping categories actually. Here in variables, age and student names are as examples. Then comes functions. Functions are a set of command key stored inside a particular name which we can use to perform certain tasks, like we use print to print something. Here input is used, a function is used to take an input of something. Len, this function gives the size of a string. Then comes classes. Here the student, card, employees, these are the example of classes. We will learn more about classes and modules later. Modules are like much likely as the functions, but these are also in math the datas are given for which we can easily use mathematical equations, random OS. All these are examples of modules. Now lexical rules, initializer standards. Character lead constant. An identifier must exclusively start with an alphabet letter upper or lower or a functional underscore this. We have to follow these rules to name a identifier, otherwise it will be invalid. Numeric base digits are allowed at subsequent stages, but leading an identifier token with a digit triggers an immediate compiler pursuing failure. Here name it is acceptable, dash the underscore then roll it is acceptable, student then digit it is acceptable. But if we start the name of an identifier with the digit, then it is not valid. Here same 9 marks, this is not valid. 1 2 3 student, this is also not valid. So we have to keep in mind what rules we have to uh, follow to name a identifier. Now comes special character constants. Forbidden structural tokens. Identifier must remain entirely contiguous. Internal spaces, dashes or operator symbols are strictly barred because they alter code syntax interpretations. The standard underscore character serves as the universally recognized connector for complex multi-word variables. Here, syntax violation which are illegal, that is student name equal to Rahul has space. Here this space is not acceptable. Here this space is not acceptable. Sorry. Student dash name then Rahul has hyphen. This hyphen is not acceptable here. Student dollar then Rahul has symbol. This dollar symbol is not acceptable. These are illegal and raises syntax violations. Complaint layouts legal. Student name equal to Rahul. This is legal and we can use it. Student name equal to Rahul. This is also legal. Case sensitivity under the hood. Image demonstrating lexical parametric maps routing lowercase name, uppercase capitalized name, and blockcase fully in capital name down in three separate data object bins inside the memory. Python treats casing alterations as strict separation. Shifting character casing redirects the internal symbol parsing loop to evaluate against a completely standalone memory reference lookup slot. Name equal to Rahul, name equal to Aman, and name equal to Python. Calling one will never leak or override data across the others. If the cases used in this same name are different, then this means that these three have different memory locations and these three represents three different identifiers of variable names. Now keywords are not identifiers. We have to keep in mind, it is very important that keywords are not identifiers. Reserved vocabulary protection. System keywords belong exclusively to Python's internal parsing engine. Attempting to hijack or overlay these reserved keywords as variable triggers immediate syntax exceptions, such as invalid will crash compiler. For 100 class equal to Python. These for and class are reserved keywords and we cannot use this as identifier names, because when we use this as identifier names, we are trying to override the reserved keywords, which is illegal. Now valid program, if we write course equal to Python, limit equal to 100, these are not reserved keywords and can be used as identifiers. Now, enterprise readability standards. Obscure, fragile, vague naming layouts have minimal keystroke but introduce heavy technical debt during maintenance view. Here, writing a equal to b 100, b equal to 200 temp 1 equal to a plus b. This might seem very easy because we have to write less, but when processing this can lead to certain technical glitches, such as a equal to 100. We don't know what a is storing or what b is storing. If we name it in a technical way or in a proper naming layout, then we can understand what this 100 represents and what this 200 represents. Here is an example of it. Self-documenting standard. Explicit identifiers instantly convey structural intent or to engineering teams without additional commentary blocks. Student name equal to Rahul, total marks equal to 450, phone number equal to 9999. So we know that what this Rahul uh, represents, what student name stores, or what total marks stores or 450 is, what this represents. We all know because we give a meaningful name to the identifiers, which helps us to identify what the value represents. Now, part 1, checkpoint evaluation. Which of the following token represents a fully valid legal identifiers? Three options are given: to student, student name and student age. Here obviously third one is the correct answer because this is the only option which follows the rules we have already discussed. Interview blueprint team. What is an identifier? A programmer defines a string token assigned as a unique reference linked to locate variables, functions, modules, or objects inside memory are known as identifiers.